Okay, everybody, today we're going to go ahead and take notes over the beginning of our Power Standard number 12, which Power Standard number 12 deals with statistics. And in statistics, what we're talking about is gathering data, maybe such as test grades or temperatures, and then we're interpreting that data using different measures. And we have three measures of center that you can see on your foldable here, and those are the mean, which we also call an average. Maybe you're used to hearing the word average for mean. And then we have the median, which is the middle of your data. And then we have mode, which is our data that shows up the most. All of those are measures of center. Those are each one way that we can figure out the center of our data that we collect. And then range actually shows a measure of spread. And what you all learned last year, hopefully learned in elementary school, was that range starts off with being the difference between your greatest and least value in your data set. So that's what we're going to talk about today, and then there's actually a little bit extra now that we have to learn about range. So let's go ahead and start on our notes. We're of course going to start with mean. So on the inside here, a few things about the mean. Our mean is actually the sum of the data divided by the number of pieces of data. So that means we're going to add up our data amounts, and then we're going to divide that total by however many pieces of data we had collected. Okay, and the mean is the balance point for our data sets that we will be looking at. The mean also describes the center of a data distribution, and distribution, what we mean by that is distribution is a set of data, distribution of a data set shows the arrangement of your data values. So it shows all the data values essentially. Now to find our mean or average, our first step is to always add all of the values. Then once we've added them, we divide the sum by the number of values that we had in the set. So again, we're going to add up all of our data numbers, and then we're going to divide that total by how many values we had. Now keep in mind that if 0 is one of the numbers or values in your data set, you do still always count that in terms of your number of values. Okay, just because 0 technically means nothing, you still want to collect that or show that as piece of your data. So let's look at this example here. We have a bar graph, and we're going to use that bar graph to create our distribution of data and then calculate our mean, the average age of these dance instructors. So what we mean by creating your distribution is just simply taking your data set and putting it together. So here we have a value of 23, then we have a value of 30, 26, 25, and 21. So that would be my distribution. They don't have to be in order right now for a distribution. It's just simply showing you what your data is. Now we're going to find the mean or the average. Remember that step 1 is to add all of the values. So I'm going to take all my values, and we're going to need to write it really small here so we can fit them in. And I'm going to add them together. Okay, so I went ahead and listed them all out, and let's start adding. We have 3 plus 0 is still 3, plus 6 more is 9, plus 5 would be 14, plus 1 more is 15. Carry my 1. 1 plus 2 would be 3, 3 more is 6, plus 2 is 8, plus 2 more is 10, and then plus 2 more is 12. So I have 125 for my sum. Once I get that total, then I'm going to divide that sum or total by the number of values that we had. So I'm going to take that 125 and I'm going to divide it by 1, 2, 3, 4, 5 values. Okay, 5 does not fit into 1, 5 fits into 12 2 times. 2 times 5 is 10. I would have 2 left over and bring my 5 down. 5 fits into 25 5 times, and 5 times 5 is 25. Nothing left over. So that means my average or my mean age for these dance instructors is 25. Okay, that's the average. Now, of course, not all of them are at age 25, but collectively their average age is around 25. Okay, so now let's go ahead and talk about Median. Again, you know median as being like the middle, and that's still true in what we're going to talk about and remind you about today. So the median is the middle value in a set of data. If the set of data has an odd number of values, okay, it will be exactly the middle number. Or it's going to be the mean, the average that we just talked about, of the two middle values in a data set. And that will happen if the data set has an even number of values. So if your data set has an even number of values, when you get to the middle, you'll see 2 in the middle, and you'll figure out the average or the mean of those to tell us what your median is. Step 1 for figuring out your median is to always put your values in order from least, oops, almost misspelled least to greatest. Okay, and then once you have them in order from least to greatest, you just simply count to the middle. Okay, so let's look at an example over here. Here's our data set. First thing we do is put them in order from least to greatest. When I do this, I always look for the smallest number first, which in this case would be 2, and I cross it out so I know I don't forget it, and so I know I don't do it more than once. And then I see a 3, and then I have another 3, then it would be 5, then 8, then 9, and then 12. Okay, so now that I have them in order from least to greatest, I'm literally going to count to the middle. So I always use my fingers and I cover one on the left, one on the right. Then another one on the left, another one on the right. Another one on the left, another one on the right, until I get as close as I can to the middle. In this case, since we had an odd number of data, we had 1, 2, 3, 4, 5, 6, 7 data values in our set. Since we had an odd number, that means it's going to be the middle value exactly, which is 5. So the median for this set of data would be 5. Let's go ahead and talk about mode now. So for our mode, you guys are used to that being the one that shows up the most in our data set, and again, that's still true. So the mode is the value or values, meaning sometimes you can have more than one, that occur most often in a data set. So the mode is what occurs most often in a set of data. So let's look at our example here. My data set has 112, 103, 121, and 104. Do I see any that occur more than the others? In other words, is there one that occurs twice or 3 times? No, I actually don't see any. So the mode of this data set would actually be none. Okay, there are none that occur more than once. Okay, so our answer would literally be that there is no mode because none of them occur more than one time. So let's make a little note here that there can be more than one answer or none at all. So for the mode, we could have more than one answer. Maybe 2 numbers show up twice in our data set, or we might not have any at all that show up more than once in our data set. Okay, let's go ahead and talk about range now. This is going to be probably the most information, and this is the one that we did have some changes, some new things that you need to learn that you didn't learn in elementary school. So first of all, the range is used to describe the distribution or spread of your data. Tells you how far apart your data is, how much does it spread out. Okay, a quartile, that's a good vocabulary word we need to pay attention to. A quartile is one measure of variation that we look at when we talk about spread. Variation meaning differences. Okay, so a quartile separates a data set into 4 equal parts. And the way you can remember that is the prefix quart, like kind of you think of a quart, there's 4 quarts. Okay, you think of a quarter, okay, there's 4 quarters in a dollar. Okay, so that's what will help you remember that a quartile separates our data into 4 equal parts. Now, the first and third quartiles that we'll be looking at, those are the medians of the data values less than the overall median, that would be called our first quartile, and it's the data values greater than the overall median, which is the third quartile. So just think about our median is the middle of our data, and then the middle of the lesser part is the first quartile, the middle of the greater part is the third quartile. Then we have something called an interquartile range. Okay, and an interquartile range is the difference between the first and third quartile of the data set. Okay, and range, that's the difference between the greatest and the least data values, and that's what you're already familiar with. So notice that's just a small part of what we're really talking about in terms of spread of our data now. So let's look at an example and figure these things out. Here's our data set up here, and first we're going to start by determining the range of the data set. Now I normally, if they're not already in order, I go ahead and put them in order from least to greatest. So we have 2, and then we have 4, then 6, then another 6, then I have 8, oops, and then 11, okay, then 13, and then 24. Okay, so I put them in order from least to greatest. And the reason I did that is because we want to know the range. Remember, the word just range means the difference between the greatest and the least of the data values. So all I have to do is subtract the greatest number and the least number. So 24 minus 2 would give me 22 for the range. Okay, that's what we learned in elementary school. Now we want to know the median and the first and third quartiles. Remember, when we figure out median, we have to have our data in order from least to greatest, which is why I already did that. So let's find our median, starting with 1 on the left, 1 on the right, and then move in towards the center. Notice we actually have 2 numbers for our median here. So that means I add 8 plus 6 and I get 14, and then I divide that 14 by 2 because that's how many numbers I added together, and I get 7. Remember that when you have 2 numbers for your median, you have to find the mean or the average of them, and the average of them is 7. So my median, the middle point of this data, is actually 7, and I'm going to write that in there. Okay, so the median equals 7. We want to know our first and third quartiles now. This is the new stuff. The first quartile, if you remember from the example or the notes over here, the first quartile is going to be the median to the left. So all of the numbers to the left of the true middle point. Okay, so notice these are the only numbers to the left of my median of 7. So I'm going to find the middle of those. Well, what's in between 4 and 6? Because those are technically in the middle. Well, the number that's in between 4 and 6 is 5. If you were to add 4 plus 6, I get 10, cut that in half, and I get 5 for my middle or the mean of those two. So my first quartile is 5. My third quartile means I need to look at the numbers greater than my median. So over here, I need to find the middle number of these. Well, as I move towards the middle, I see 2 in between again. Well, what's in between 11 and 13? What's the average of those? That would be 12. Okay, so there's my first and third quartiles. Now our interquartile range, that is actually going to be where we take our third quartile number and we subtract out our first quartile. Okay, so we take our third quartile and subtract our first quartile, and 12 minus 5 is 7. So that's our IQR, or interquartile range. Now, outliers is something that is brand new to us that we also need to talk about. We need to name any outliers that are in our data set. So as far as outliers, the definition of that, we're going to write right over here in just a moment. Okay guys, sorry, I ran out of time, so I merged 2 videos together. So we were talking about outliers. So once we figure out what our median of our overall data is, and then we figure out what our first quartile number is, which is the middle of the lower half of our median, and then we figure out what the third quartile is, which is the median of the upper half of our data, then we can figure out our IQR, that interquartile range. Now, what we mean by outliers that we need to figure out now is, and we're going to write the definition of outliers over here, outliers are numbers that are 1.5 times less than the first quartile or 1.5 times greater than the third quartile. So in other words, outliers are numbers that go too far beyond the middle of our upper half of our data set, or too far beyond the middle of the lower half of our data set. We call those outliers. They're kind of the outsiders. They don't really make sense in our data. Okay, so we want to know if there's any outliers in this particular set of data. So to figure that out, we first need to start by figuring out what 1.5 times our IQR is. And so we use the IQR number, our interquartile range, and we're going to multiply that by 1.5. So we're going to take that 7 and multiply it by 1.5. 7 times 5 is 35. 7 times 1 is 7, plus 3 more is 10. Okay, so I'm going to circle. I have one place value behind my decimal point. That means we got 10.5. Now we said this number, okay, is going to help us figure out the numbers that are 1.5 times less than the others. So I'm going to take my first quartile number, which up here we got for our first quartile, we got 5. I'm going to take 5 and I'm going to subtract 10.5 to figure out how far to the left of this can my numbers be. Well, when I take a whole number of positive 5 and subtract 10.5, I get a negative 5.5. So as long as none of our values on the left side of our median are farther out than negative 5.5, there are no outliers over here. So on this side of our data, since nothing is less than negative 5.5, we don't have any outliers on the left side of our data. But what about the right side? Well, we're going to take that third quartile number, that 12, and I'm going to subtract 10.5 from that. Excuse me, I'm going to add it. I'm going to add it because it's greater. Excuse me, we're adding because we want to know what's 10.5 greater than our interquartile range over here, our third quartile. So 12 plus 10.5 is going to give us 22.5. So 22.5 is our limit for over here. If there's anything larger than 22.5, that's considered an outlier or too far outside of our data set. So do we have an outlier on the right side of our data? Yes, we do. That 24 is greater than 22.5, so we have one outlier in this set of data. Okay, please make sure you have all your notes complete and you're ready for class tomorrow. Have a good afternoon.